All right. Hi. I hope you can hear me. Don't know if you can hear me.
Yes,
Yes, we can. Yes.
All right. Thank you. So, as always, just wanted to find out if there are any questions with regards to what we did the last time we met. So we wrapped up file systems, file organization, and file systems essentially. Hopefully, people have gotten to a stage where they fully understand exactly why we need to logically organize data in a computer system. For the most part, it benefits human beings, so people like myself and you people out there, because it turns out that it's a lot easier for us to be able to better interpret data, the streams of ones and zeros, that way, rather than looking at the ones and the zeros, right? And most of this will probably make sense once we start looking at data encoding, right, which is very, very soon. I do believe we're just about a lecture series away from doing that. So which is good. Then also, as a reminder that we're actually, it turns out we're setting the stage for lecture series number 13, which is essentially just a brief walkthrough of secondary storage, computer memory. So we were trying to set the stage for this. And it turns out that in lecture series number 13, what we normally do when we discuss secondary storage is we tend to well, we tend to gloss over what I did there, but we tend to gloss over different storage mediums that are available out there. And it turns out that there's a whole bunch of them, right? And then at some stage, we look at certain operations that we get to perform on data, right? And this is different from the operations we spoke about when referring to files here, like cutting, copying, and pasting. And primarily what we do is we tend to focus on, things like backup strategies, for instance, because it turns out that once you generate these massive amounts of data and you want to persistently store it somewhere, one of the things you want to ensure is that the data is safe, right? Safe in terms of you wanting to gain access to it at a future point in time, let's say 10 or 5 years from now. So what exactly do you get to do? You backup, right? So this whole notion of backup and restore anyway. And then that's it. Okay, so if there are no questions with regards to what we did, yes, last time we met, can't remember when, we shall proceed, unless if there are any questions. Okay, all clear, I suppose. That's good stuff. But before we start, right, we sent out an email about the regrading process. And we're regrading these things, and I just got curious, and I went up there to look at the stats, and I thought it was very, very strange that a lot of people struggled with quiz number 8, right? And I guess, I don't know, I'm trying to find out what the problem is here, but I'll pause. I would like for you to think about what the problem, and then maybe you can share your thoughts about what the problem is, try and see if you can make things slightly better or bearable. Seeing as we are, technically speaking, we're about halfway through the course itself. Right now, this is what I'm talking about right here. This is what's worrying me here. Well, I just got curious. I thought it was really strange that only a handful of people passed, essentially. Right? I thought it was a very trivial quiz. Right? I mean, if you look at this really ugly snapshot here, it's worrying. Eh? Very worrying, at least for me, anyway. It's not normal that we can have 44 of you getting D's in the quiz, right? That to me was a pretty easy quiz, and there's a reason why we're saying it was an easy quiz. We we noticed that there were some people that pretty much were able to get literally everything correct, right? So there's an issue here, right? There's an issue, and really this issue, we can see it in the distribution of the scores. This is not normal, right? I think a while back I introduced us to this whole notion of so-called bell curve, and this is our high, right? This is what we were hunting for or searching for. Is not normal, right? This is what I was talking about here. You know, I mean, so if we can have these people here, so it's good stuff, by the way, if you're here, right? If we can have these people here perform as well as they did, the question we should be asking ourselves here, right? The question we should be asking ourselves is, what exactly is wrong with the 44, right? I don't know if the Bible has the 44, that I don't know if it's the 44 or something, but what exactly is wrong with these people here, right? What's happening here? What is the problem? I'm going to pause here because I wasn't going to do this, but I thought I would pause here and just try and find out if there's something that people are struggling with, so that we can fix this before we proceed, right? Especially before we proceed with the second half of the course, which requires a little bit of additional imagination here. Any thoughts about why you think the performance was bad? I mean, you can speak for yourself. Obviously, you can't speak for the rest of the class because you don't know, right? So like you've conducted a survey. But if you're amongst the 44, what exactly was the challenge for you? What was the problem? What did you struggle with? Where's Maggie? Maggie? Where is she? She's not here. She was in the test, but she's not here. Okay, so then there's no problem. So then the conclusion is that maybe you just didn't read or something. You didn't study. She's there and she's pretending like she's not there. Maggie Zul, what was your problem?
Sir, actually, I missed most of the lectures, so I didn't really know what was really going on.
Wait a minute here. What we do in this course, right, Zulu Maggie, what we do in this course is that if you don't attend class, like I don't know if it's the almost is it 50 plus people that are not attending today's class, we know that this session is going to be recorded and it's going to be made available. The chat transcripts are going to be made available. The slides are made available. So irrespective of whether you miss class or not, you should be able to catch up, right? This is worrying here. Patrick Muila, what happened? Ooh.
To start with, sir, I actually thought I did the calculations correct, but after going through the solutions that you sent, I actually find out where I missed what I was supposed to do, and I have nothing to say.
That's good right there.
I missed my part. So
yes, pardon? Sorry. Continue. Sorry, I'll talk after you're done. I apologize for that.
Oh, yeah, I was saying that I just missed a part of my calculation. I was because of time. I have this experience because of time. I was doing the calculations like in my head. That's the part where I made the confusion. Like when converting from the GBs to the megabyte, I'll just multiply by 1024, and then when I get to converting to the bits, I do the 1000, and then I just sum up the calculations. So after going through step by step, looking at the time, I actually discovered that I missed exactly what I had to do, and the solutions I gave out, I was even shy because they were not logical at all. So on my part, I just missed the calculation. I hope I'll do better next time.
Yeah, I mean, what's important is I'm glad that you brought up an important thing here, right? The fact that you've identified where the problem is, right? So, but if you're not like Patrick, and if you're one of those people who doesn't know, right, where the problem is here, here's an olive branch. You can always reach out to us, try and see if we can help somehow, right? Um, but also, we keep saying that there's a reason why we normally beam up NS name, for instance, right? The reason is so that you can, if you feel comfortable approaching these people rather than Lighton, what you can do is you can reach out to them and ask for help. And sometimes asking for help doesn't necessarily mean you asking that NS logs on and then you have it. But maybe it might just be of help if you asked him what works for him, how he's able to do this. Maybe he's come up with a formula that works for him, right? Now, it's not just NS here. There are some names here. If you look up the previous leaderboards that we've shared, you notice that there's some names that are always appearing here on the list. What that tells us is that now maybe they're probably freaks of nature, right? Maybe the high IQs and whatnot. But it may very well be the case that they've figured out how best to approach this course, right? So you want to sit down with them, reach out to them, and ask them. There's no harm in asking, and in fact, I do encourage you to ask, right? This is how you learn, you know. So I don't know here. This is any other thoughts about the quiz? Those of you that got low marks, what was your, what do you think was your weakness when you went through the solutions? Were you able to figure out what the problem was, what mistakes you made or something?
Yes, sir.
What was the problem?
I figured out that the first question, the way I answered it was partially correct. I didn't finish it up. When I was going through them again, my answer was incomplete. And then I don't know about the third question. I'm not complaining, but the system didn't save my answer there. So I'll do better this Friday.
Yeah, oh, yes. We must do better this Friday, right?
Yes.
Thank God it's going to be Friday, I suppose. I don't know. Okay. Yeah. I don't know about this third question you're talking about. It turns out we randomized this question. So your third question might...
It shows that I didn't answer the question when I actually did.
Okay.
Yes.
That's sad. Any other thoughts? Is there something that you think is, if there's anyone struggling with understanding certain parts of the course here, maybe Lighton doesn't explain things as well as he should. Oh, but maybe, right? If that's the case, you must tell us, right? That maybe that's the case. What do you think is a problem? Any thoughts? I don't know. What do you think is a problem here? Okay, you want to talk? That's fine. Yes.
Another thing, sir. I figured this out last time. I was going through the questions first, trying to understand them before solving them. So
right.
When I got back to start solving them, I was at the 12-minute mark, and
yeah, that's...
and coming to I couldn't use my PC calculator, so I was using my phone calculator and notepad to write down the figures. So I figured the way to go is to go through question by question, you yourself assuming which one's better to solve first, rather than go through them all and then trying to pick from there. So In the end, all I could get was a B. Well, that's all, sir. That's all.
A B is good enough, right? The final exam and the other tests that we're supposed to write. Because it turns out one of the things you'd have to, at least this approach that I used to take when I was a student myself, what I would do is I would tackle all hanging fruit first, right? So you go through the questions. Going through the questions is a good thing. You go through the questions and then you identify which ones are the easiest questions, right? And then you tackle them first because you're assured of those marks, right? Rather than going through the questions sequence by sequence. Bad idea, right? So hopefully as we are writing these quizzes, and there's 2 more quizzes coming because we're on 9, we have to get up to 20 here. So it's going to be a marathon now, week by week, right? So this is the thing here. This is you have to figure out, and I'm not saying here that the strategy that you should take up is one where you start with low-hanging fruit, right? For some people, what they would want to do is to start with questions that have the most marks, right? But the important thing is for you to figure out a system that works for you. And really the other thing is to study, right? Don't wait until the end. Every time we have class, find time that very day or the following day to revise and to understand or to try and look up things that were a bit iffy when Lighton was lecturing or something. And I'm saying this because I pass through the chat transcript sometimes, and I don't know if people are joking when they say, no, I can't understand anything he's saying. The reason why you're in school is because you don't know. You need to be taught so that you know, right? If you don't know something, if you don't understand something, you better write it down, right, during the lecture. After the lecture, you look it up so that you understand further. It's the reason it's called a lecture, right? It's meant to open your mind up, and then afterwards you're supposed to go and do a little bit of additional research on your own. And the best place to do research from is the prescribed text, right? Anyway, I just thought this was really sad, which is why I thought we would have this conversation here. It was very depressing. Oh, I wonder how it was like last year. I don't think last year it was this bad. Yes, hey, look at this, right? Let me show you something. Let's go last year today, right? Well, last year now, I suppose, not today. But if you look at the performance last year, I hope we'll be able to find the performance last year or something. You will notice that, oh wow, I don't have, you'll notice that the performance of last year's cohort was probably somewhat better, I guess. Whew, I don't know where this is, but this is lecture number 8. I don't know what we are doing here, but let me see if we can find primary memory, if we can find the thing we want here. No. But if you were to look up the scores from last year, what you will notice is that the performance was pretty decent, right? It's pretty decent, much better than your performance. Now, we don't know what that means, right? Maybe, I don't know. Maybe it means this cohort is not very smart now, is it? Anyway, it's not here, but I wish I could have found it so that we could compare the results from last year and this year. Anyway.
Physical learning is far much better than online. So
sorry?
Physical learning compared to online learning. So you wouldn't expect the results to be maybe the same or something.
That may very well be the case, right, Master Tembo, and thanks for that. That's a nice way of looking at things. But the way I look at what's happening here is that what you people are doing is you are writing an open book. You're writing open book assessments. You literally have access to resources, the internet, the notes. You actually have 10 extra minutes, twice as much time as last year. But in essence, the complexity of the question is pretty much the same, right? So I don't know what that means here, right? So many factors. I guess we'd have to do some sort of superficial research trying to figure out what the problem is here. But anyway, so we proceed as planned. If you think of anything else that you think is worth sharing with Lighton with regards to why you personally performed poorly in quiz number 8, please reach out to Lighton and tell him. As is the case, if you are shy, if you're too shy to speak your mind up, which is fine. I suppose I used to be shy myself. No, I don't think I was. Maybe I was, I don't know. All right. So just a reminder though, that day after tomorrow we have a quiz, right? Quiz number 9. Quiz number 9 is going to be based on lecture series number 11. So you want to make sure that you read up on that. It's a short, it was a relatively short lecture series, right? I think 70 slides or something, pretty much less because some of the slides are like animations. Please read up on what we discussed, things to do with memory hierarchy, for instance, the purpose of the different types of memory components, the different aspects that we sort of like take into account when we're evaluating memory components, right? So things like size or capacity, cost, throughput, latency, proximity to the CPU, all those nice things that we discussed. I do apologize, the noise. We live close to very unruly people. So please, please study for this this assessment. I'm worried here that the performance is really bad, and we're almost getting through to quiz number 10, right? So in an ideal case, we're expecting that the performance would be bad all the way up to somewhere around quiz number 5, number 6, and then afterwards, people would start performing much, much better. But maybe people are not studying. I think that's what I suspect. And I know you're at home, all you're doing is just eating and watching TV. No, I'll read that useless course later on, right? Don't do that. This is your future at stake. The exam is very, very soon, after next month. Okay, so if there are no other questions, please study for the test. We proceed with lecture series number 13. Lecture series number 13 is pretty interesting. I have a lot of stories about lecture series number 13, which is why I find it really interesting. In part because in my previous life, I did work as so-called database administrator. And it's not like I worked as a DBA through and through, but I also did, we did a bit of extensive backups, right? I used to work for I used to work in the telecommunications sector. I used to work for, they used to call them what? Celltel, and then they rebranded to Zen, and then Airtel. I worked with them for almost 4 years. It was good. We would back up stuff, data, to tape and network storage. So I have a lot of nice stories about this. I really enjoy talking about this lecture series here. But essentially, what we're going to gloss over is just to discuss so-called storage mediums, right? So these electronic components that we use to persistently store data and instructions. And then we'll look at we'll just gloss over broad categories of different types of storage mediums, right, with a few examples. And then focus more on issues to do with some operations that you tend to perform insofar as data and persistent storage is concerned. And then towards the end, we'll wrap up by just looking at some evaluation aspects that we need to take into account when you're evaluating different types of storage mediums. And what you will understand, or what you'll notice when we start looking at this part here, the evaluation of storage mediums, is that the same things, I don't know if you've picked up on this, but these different aspects we've been talking about are always going to pop up, right? Cost. If you remember, these aspects to do with cost and efficiency or performance, we started talking about this when we began our discussion of a history of so-called computer systems. I don't know if you remember this, right? So it turns out that those aspects are more or less the same, right? So we'll discuss these different aspects so that if you find yourself in a situation where you are wanting to evaluate which storage medium is the best, you'll be able to come up with, you'll be able to make an informed decision as to whether you should back up to tape or if you should buy a slightly more expensive storage medium like a storage device like a magnetic more magnetic storage, like what do you call this? Oh my God, it's storage. Oh, I don't know. I've forgotten. I don't know what's happening here. I just forgot what I wanted to say. Yeah, anyway, so doing an evaluation of whether you want to go for magnetic storage or optical storage, right? There's a lot of interesting things in the area of optical storage, right? People are doing crazy things like, we don't talk about this, but maybe it's something worth looking into, I guess, don't know. I was watching a documentary not so long ago about how to storing data on, they're storing data on glass now, right? Massive amounts of data, right? This I guess it's still in experimental stage here. Maybe we should incorporate this in our discussion. But also crazy things like this shows you how important data is, right? Persistently storing data. Crazy things like I don't know if you've heard of what how Microsoft cloud storage. How is it Microsoft underwater? How Microsoft doing crazy things like trying to see if they can store, they can build data centers. About this, maybe I was watching how they're doing this. So instead of setting up your data center away from like a CBD or something where you build infrastructure, what these people are doing is they're dumping pods underwater, right? And so data is being stored in these pods. And the idea behind this is that cooling, because cooling infrastructure that you use to persistently store data is expensive. The servers that you use, right? The server computer systems that you use have to be cooled somehow, right? For you to cool them, you pretty much would need electricity or something. But if you put them underwater, it becomes a lot cheaper for you to do that. Okay, so this is what we're going to talk about. I'm just going to proceed here. This has become second nature, guys, right? This idea that we are still studying a computer system, like this electronic device that accepts input, processes the input, and then presents the changed input as output. Optionally, you can store the processed input, right? Which is where memory comes in, the secondary memory computer storage. Right? So this is, again, this has become second nature. The part that we are mostly interested in this lecture series is this part here, right? Where we persistently store data once it's processed, so that we can refer to it afterwards. And the interesting thing about this is that once you persistently store data, it turns out that you go back in a loop, right? So imagine a situation where you record a selfie. I mean, you recorded. I don't know if people use TikTok here, right? You record a video. At some stage, you're going to have to make reference to that video, right? It's persistently stored somewhere, but you're going to have to make reference to it. Once you make reference to that video, by using computer software to access it, to play it back, what you're doing is you're going back through the loop, right? Because the persistently stored data is going to be used as input, right? And then you use the CPU to process that input so that you view or you play back the video, right? So you go back in this loop. Essentially, it's like Sisyphus now. You go back in this loop. All right. Again, we're still looking at the memory component here. Just to kind of rub it in here with regards to to try and latch on to our previous discussion of primary memory. A reminder here that there are certain characteristics that are specific to primary memory. So things like it's much faster than secondary storage. It's volatile, right? Unlike secondary storage, which we'll soon discover is non-volatile. It's slightly more expensive, obviously, because of the components that are used to manufacture because of the technology used to manufacture the memory components themselves, which is why it's a premium, and so we have less of it typically. And in fact, as you move closer to the CPU, we realize that we have far less of it, right? Think of registers and CPU cache and compare them with things like virtual memory and RAM or ROM, right? And again, just to remind us that the idea behind the stored program concept still holds here, right? This memory unit, irrespective of whether we're talking about primary memory or secondary memory, is essentially used to store data and program instructions, right? And this makes sense because at some stage when we went through the life cycle, yes, sir.
Are we going through lecture 11 slides or?
No, this is lecture number 13.
Oh.
Yeah. Right. Right. So a reminder here that if you think about this, well, both data and instructions are stored in the same memory component. So this applies to secondary storage as well. If you remember our discussion of the life cycle of the computer program, we discovered that initially those program instructions, the program that we double click, is stored on secondary storage. Once you launch it, it's going to be loaded into primary storage, which is typically RAM, and then it's processed, right? All right, and so our focus now is on this bottom layer of the pyramid, and you immediately notice that those characteristics we spoke about are somewhat different here. And I want to draw attention to things like power, right? So the data that you store on secondary storage mediums is typically going to be persistent irrespective of whether you're supplying electricity to the memory component, right? So think of a flash drive, a flash disk, for instance. The data is still going to persist irrespective of whether it's connected to a computer system or something. But also in terms of things like capacity, because the cost is much, much lower, and because you typically, for the most part, you typically have these storage devices or storage mediums located outside of the computer system, you'd be dealing with significantly larger components, right? I wish I had my webcam here. I could have shown you some of the external storage devices that I have, but I think there's a slide that talks about that, I think. Yeah, okay. There's a slide, we'll look at that, you know. So the size is somewhat larger, right? It's larger because the form factor of the computer system is no longer something that you take into account, because typically these storage mediums would be connected to the computer via the ports, right? So they're external. So there's nothing like I have a laptop that is too thin for it to accommodate additional external storage, right? Because you can literally plug it in externally. But also the cost, because it's much, much cheaper, you can easily have access to significantly larger storage, right? So cost. Unfortunately though, the speed, the rate at which data gets to be transmitted to and from secondary storage mediums or devices is much, much slower in comparison to primary memory, right? But that's fine, because typically what we do when we are interacting with computer storage or secondary storage is we're just making reference to something that has already been processed. If it needs to be reprocessed, which is almost always the case, all we do is we move it to a much faster location, which is RAM, and then the fetch to code execute cycle starts from there. Right. So a few obvious things that I think we discussed in lecture series number, I don't know if it was number 11, number 10 or something, the fact that secondary storage, the purpose of secondary storage is to persistently store data. So the idea behind secondary storage is for it to facilitate the long-term preservation of data. So if you have intentions of storing data beyond you switching off your machine, then you're better off storing it onto secondary storage or secondary memory. So it's non-volatile, right? Meaning that irrespective of whether or not you have electricity being supplied to it, data is going to be persistent, right? It'll still be there. It's significantly larger in size, like we earlier said, much larger capacity. Because literally, in almost all the time, every time you are processing data, it's pretty much going to be destined to secondary storage, right? So you need more of it, essentially. In certain instances, where a brand new computer will come bundled with secondary storage component, right? Internal storage, as they call it. It's usually located somewhere within, is it your system unit if you're dealing with a desktop, for instance. Again, it's there so that you use it to preserve or to store data over a long period of time. And there's a caveat though, right? People have, there's a misconception that there's this misconception that if you write data to tape, for instance, that's it, right? It will always be there. That's not the case. Just like most things in life, these storage mediums and storage devices that we use, storage mediums especially, they'll wear out, right? And so a cheap trick or a technique that is used is after a certain period of time, what you do is you move the data to a different storage medium. So let's say this year you decide to archive data to a CD, for instance. Maybe after 10 years, you might want to move that data to a different storage medium because there's usually wear and tear, right, associated with the sort of storage components. Right, again, so this secondary storage is it's used as a staging area when you are launching applications for the first time, and we know the life cycle now. So from secondary storage, once you execute the program, it's going to be loaded into RAM, and then from RAM, it takes a trip to the CPU. In the process, passing through different memory components like CPU cache, for instance, where it's going to be cached in the event that you want to make reference to the same type of data. And then once you get to the CPU, the data is going to traverse different storage locations that we introduce as registers, right? And we looked at different types of special purpose registers, things like the MAR, the MBR or MDR, the program counters of this world, right? We know what they do right now. Those are all memory components, right? Now, so in terms of the obvious benefits or advantages of secondary storage, I guess this is pretty much obvious by now, is you have access to a lot more of it. And because you have access to a lot more of it, you can store more data onto the storage medium, right? It's also cheap, which is why you can gain access to a lot more of it, actually, right? Think of the cost in relation to more expensive memory components like RAM, for instance. How many of you guys are able to just wake up one day and decide to say, I am going to buy 20 GB of RAM today? Very few, right? But I'll bet you perhaps more than half of you can manage to wake up and decide to say, I am going to buy a micro USB card that is 128 gigabytes in size. I was at Eastpak the other day. I was in this electronics store. I don't normally do that because I buy my things online. And I got curious because they had in stock 64 GB and 128 GB micro SD cards, right? And I think when I asked how much it was, I believe they said the 128 GB was going for, was that almost 300 kwacha or something? RAM is expensive on the other hand, right? For you to just buy, I guess a DIMM that has a capacity of about 2 GB in size, you probably have to fork out maybe a couple of thousand kwachas for you to gain access to that sort of memory, right? So cost, and then also I guess reliability as well, right? You tend to, usually when you're buying storage, something that people miss out is the fine print associated with the lifespan. It turns out the manufacturer will specify what lifespan is associated with the storage. So when you go out there and you buy a CD, somewhere on that CD, maybe on the cover, they'll tell you the lifespan. Maybe they'll tell you to say after 15 years, they'll guarantee that data can be stored on that storage medium for at least 15 years or at least 20 years, right? Good stuff. I'm thinking there's another aspect that we perhaps missed out. Capacity, cost, reliability, persistency, right? I don't have to worry about, oh, power just ran out and I'm out of power. Who cares, right? The major drawback, though, is efficiency, right? It's much, much slower, right? And this explains why, if you remember, we introduced the notion of virtual memory, the fact that you can convert part of secondary storage into RAM, and the computer will be able to perceive it as being primary memory. But the downside or the drawback of that is that access to program instructions that are going to be loaded into virtual memory is going to be dog slow, right? Again, a reminder that we're at the bottom layer there. Yes, sir.
So in terms of virtual memory, both the emulator and the software's instructions are going to be loaded into RAM, right?
What emulator?
VirtualBox.
Yeah, but why are we talking about VirtualBox? Do you want to explain a bit more about your?
No, you talked about you said something about it's about, that's why you gave an example of what happened last time when you told us to use VirtualBox to run an operating system on an already existing operating system. So sorry to go off the topic, but does that mean both instructions associated with VirtualBox and instructions associated with the operating system are loaded into RAM? Oh, sorry,
yes.
Right.
Into RAM, yes.
Yes.
Everything is going to be loaded into RAM. You can do a simple experiment, right? So as you're running, and I wish I could do the experiment right now, but there's simple ways of trying, excuse me, of trying to experiment with some of these things. So, for instance, and I think I've shown you this before, right? For instance, if I start monitoring my applications like so, and I load a memory-intensive application like observe the used here. What can I load? Maybe GIMP or something. GIMP, I suppose. Once I load that application, you notice that already I'm using. This is exactly what happens when you see VirtualBox is not different from OpenOffice, from Google Chrome. As far as your operating system is concerned, it's just a bunch of instructions, right? So the same rules that apply to Chrome, Google Chrome, or Chromium will apply to VirtualBox as well. Program instructions, all of them. Anyway, I don't know if this is, but okay. So I thought in terms of the different aspects that I just spoke about here, the advantages and whatnot, what you immediately, I guess this helps contextualize things. This is an old image from last year, I think, but these happen to be some of some. I have plenty of guys. I even have 3.5-inch floppy drives, right? Which I used them when I was a student myself. Floppy disks. I don't know if you've used. I don't know if anybody has used a floppy disk before. I used a lot of these. Believe it or not, this is secondary storage, right? Magnetic storage. But these things, the ones we were using, were 1.44 megabytes. You heard me, right? Megabytes. Not enough, right? Not enough to even accommodate slides. The average slide for ICT, PDF presentation for ICT 1110. If you notice the size here we're working with, it's usually above 2 megabytes or something because of the images that are there. So yeah, I just went back in memory lane here. But anyway, so you can already see the different aspects here. You notice that the sizes are different, right? Some of them are much smaller, much larger, and the obvious advantage is to having a memory component that's much smaller, right? It's portable. You can easily move around with it. You can easily incorporate it into an embedded system, right? Like for instance, the micro USB cards that I have, I can slot them in using this extension here, right? This adapter here. I can slot them into my computer and be able to read it just like I read a thumb drive, or I can dump it into my I have a digital camera here. I can also dump it or connect it to an embedded system, which is my GoPro, for instance, right? Obvious advantages there. This thing here, I rarely move around with because it's really heavy. I think it's right about the same weight as a 2 kilogram bag of sugar, I think. The sugar that we buy in Zambia or something, I think, if not heavier, right? And so I can't move around with it. I just leave it at home most of the time, right? So different things here, right? In terms of lifespan as well, there's things to do with lifespan, and we discuss this as we're looking at the specific types of or different categories of computer storage, right? It turns out that some of them are much more durable, right? Some of them are appropriate for archival purposes. Some of them are much cheaper. Some of them are extremely slow. Like I don't have, unfortunately, I don't have tape here, right? But a tape is back up the tape. Tape is exactly that. I don't know if people in here ever use VCRs. We used to use VCRs back in the day ourselves. But it turns out that data is written on the same film as I guess it's similar technology as like what do they call those things? The ones we used to use in VCRs. I can't remember what they used to call them.
VHS.
Are they called VHS?
Oh, the tapes are also, or VHS player using a VHS tape.
We used to call them video tapes or something. I don't know what that. We used to call them video tapes. My parents still have these. I should have. Yeah, this is what we used to use. Yeah, VHS. You're right. Yeah, I don't know if this technology is still around. I'm a dinosaur. So this is the thing here, right? This is extremely slow, and part of the reason why it's slow is because it's sequential. You cannot access data randomly. So if you want to access data that's at the further end of the tape, you'd have to spool the tape and get to the location where data is written to, which is why tape is perfect for archival storage purposes. But anyway, so different aspects here, right, size and all these good things here. And so I've numbered this so that we have just a small little discussion on the next slide here. I'll be referring to this slide back and forth here, right? If you notice, I have some approximate numbers associated with these different memory components here. And you can already see that the obvious advantages here, things like the lifespan, capacity, yeah, the cost, yeah. And I should have done, unit cost here. If you look at this, the cost per gigabyte, for instance, you can already see that if you look at all these different components that I have here, the cheapest is, according to this, I guess the cheapest is number 2, which was this. So this is much cheaper than 8, for instance. 8 is the most expensive, right? Which is like 4.97 ngwe per gigabyte. It's pretty sad, right? I don't know. Right. So again, right, the decision on which particular storage medium you're going to go for is contextual. It depends on what you want to use it for. Are you planning to archive data that you accumulated when you were a student at UNZA for whatever reason you might have? In which case, you don't care about the speed. You don't care about the speed because you're archiving data. The likelihood that you're going to frequently access, you're rarely going to frequently access that data. In fact, it's likely the case that you might never access that data at all. Right? I have countless examples of data that I accumulated when I was working, for instance, or when I was a student, right? I have those things stored somewhere. But I rarely access that data, right? But I just backed it up just in case I might need to refer to it. Sometimes when I feel like gloating, right, thinking about reminiscing about the old days, I'll access data that I backed up maybe more than a decade ago, right? It's always nice. I always enjoy looking at how I used to write 10 years ago, right? Turns out I was pretty good, actually, maybe better than I am right now. But anyway, so these are some just a comparison, right? You can already see here, there's a reason why this smaller component is much more expensive. It turns out that manufacturing something that is much smaller is more expensive. Yes, sir.
What are the names of those devices? 1, 2, 3. the names.
1, 2, 3.
Are they all external hard drives?
Yeah, these are external hard drives. This is I don't know if this is a DVD or a CD. It's likely a DVD. I don't think people use DVDs anymore. I think this is a DVD. This might be a CD. Of course, this is a thumb drive, right? Thumb disk, thumb drive, or memory stick, as they call it. This is another thumb drive, memory stick. This is just an adapter. 8 is a micro SD card. Yeah, this is a solid state disk, I think. Either this or this. I think it's this or something. I think it should be 4. All right. I mean, so you notice here, right? I mean, so you'd sit down and then you ask yourself, should I really go for size? Should I go for speed? Should I go for the technology that is used to manufacture that component? Should I really look into cost? You know, am I really obsessing a lot about weight? These days, you move around a lot, I guess, if you want, because I think you do a lot of shopping, window shopping, East Park, and you want to maybe get your, I don't know why you do that, but you want to move around with your external drive, you'd look at weight, right? The last thing you'd want is you're moving in your backpack with 2 kilograms, right? 2 kilos of storage space, for what, right? So these are things to think about: portability, efficiency, capacity, cost, right? All the interesting aspects there. All right, and there's probably more aspects to look at here, right? Leave it up to you to do a bit of research, right? It would be nice if you could come up with more aspects, which is always nice. We have faith in you. And also, I guess something else to think about as you are evaluating storage, right? As you are looking at what sort of storage medium to go for is exactly the sort of data that you're storing, right? And how much of it, especially the capacity. Most people tend to focus more on really the capacity, how much of the data you want to store, neglecting the type of data that you want to store. It turns out that it might be beneficial for you to look into the type of data that you're storing onto the storage medium itself. And there are countless scenarios here. We could probably spend the whole day talking about this. UNZA, for instance, probably has some backup strategy that involves them using a wide array of different type of storage mediums, right? Why? Because when you graduate, I am sure that they need to archive your information somewhere. You archive it to a safe place so that in the event that you come back, you're a politician 5 years or 10 years down the line, and you're following up your results because people are suggesting that your degree is forged or something, you come to UNZA. What UNZA will do is they will go to their archives, right? That's a scenario. We had this weird scenario when I was working in the telecom sector where we would constantly have the police come through and with search warrants, right? To come and request for code detailed records, right? So remember, when you make a phone call, all those things are recorded, right? So who you called, when you called them, how long you spoke to them. It's just meta information, not exactly what exactly we're saying, right? But it turns out that sometimes it might be necessary to refer to those sort of details maybe 6 months or a year down the line. That's another use case. Your banks, I don't know if you've bothered to look into what banks, my bank, for instance, will generate a statement as far back as 180 days. But it doesn't mean that I can 5 years ago. They are mandated to provide me with that information. They backed it up to, obviously, secondary storage mediums like tape, so that when Lighton or some other crazy character approaches them a couple of years down the line to say, I want to gain access to my transactions from 5 years ago, they'll refer to archived data on tape or something and be able to restore it. I mean, I'm guessing you implicitly, if you don't know this already, but you implicitly back up data, right? You probably have maybe an external storage, an external hard drive or something that you use to back up movies or something, right? I don't know how many of you would perhaps be in possession of DVDs. There are high capacity DVDs these days, right? I know someone who archives their emails every year and their data on their computer every year to secondary storage. I mean, to optical storage, like to a DVD. Right, so I have these stacks and stacks of CDs. Right, so different sort of scenarios here. Is there anyone who has stored data from data they generated 5 years ago, by any chance? Are you even there? I wonder.
We are there, sir.
Yeah. Do you know backup data? Do you know store data?
I have a Dropbox account as far as ICT.
Yeah, perfect. That's the thing here, right? Dropbox, right? This is a new breed of storage. Sadly, right? Do you know the capacity, the limit for Dropbox, the free tier? I'm guessing you use the free tier.
2 GB.
2 GB, yeah.
2 GB.
Yeah. So there's something to think about, and we'll talk about evaluating storage here, right? Something to think about here is, would you want to store movies to Dropbox? That would be insane, right? Why? Because you'd have to spend a lot of money retrieving data that you've backed up to Dropbox. For you to access Dropbox, you need network access. For you to get network access, you need to buy bundles. Bundles need money, right? These are things to think about as you're coming up with a strategy of where and how you're going to store data. We'll talk about these things. Anybody else? Yes, sir.
What's the advantages of using optical storage compared to magnetic?
Cheaper. It's mass produced. It's much cheaper.
Right.
Yeah, that's one of the advantages. I mean, I think about this for a second, and also you can buy smaller quantities of it, right? If you look at this thing that I have here, great question, by the way. If you look at this magnetic storage that I have, right, all of them are like a terabyte in size, right? Yeah, look at this. But what if, here's the thing, what if I want storage so that I just store maybe a GB worth of data? Does it make economic sense for me to invest money in a 1 terabyte component, right? I would be, if I'm only interested in storing 1 GB of data, do you understand what this means? And I have 1 terabyte. 1 terabyte is like 1024 GB of data. But what I want to store is one GB of data. Why would I want to buy 1,000 times as much space as I need? Right? So that's another advantage. You can buy smaller quantities of it. You know, so anyways, guys, I'll see you when you see me, which is it tomorrow or something? Friday. Okay, so we'll continue our conversation on Friday. Enjoy your fun and take care. Bye-bye. Thank you.
Right. Clarence.